All right, guys, welcome back. So today we're going to actually combine two sections from chapter 3 together. Today we're going to take 3.2 and 3.4, and we're going to do them at the same time. I think we can handle that, and I think it almost makes it easier if we do them at the same time. You're less likely to mix the two rules up with each other. So where we're going to start. If f of x equals x squared, remember that was our parent function that we learned about last time. And it looks kind of like what I've drawn right here. It's a parabola. It goes up. It's a U shape right in the middle. Its vertex is right there at 0, 0. And it has a normal slope, up 1 over 4, or up over 1, up 1, over 2, up 4, over 3, up 9. That's kind of the normal pattern. What happens if I take something with this x squared, and instead of last time we multiplied something in front, what happens if I add something to it? So like what happens if I do f of x equals x squared plus 4 or x squared minus 7? How is that going to change my graph? So if we're going to do kind of what we did last time, I'm going to go to Desmos, and I've got a normal x squared function right here in blue. Okay, so I've got this normal x squared function. It's right in the middle. It opens up. It's got normal slope-ish stuff. But what happens if I change that? What happens if I add 3? So what if I do x squared plus 3? Look at what it does to my graph. It's still in the middle. It still looks like it's the same shape. The only difference is now it moved it up 3. So is that a coincidence? Let's do plus 5. Nope, that moved it up 5. If I do plus 1, that moves it up 1. So what do you think is going to happen if I do minus something? What happens if I do minus 4? Yep, that moves it down 4. So whatever I add or subtract, the way it changes it is going up or down. So my x squared plus 4 is still going to be right in the middle, but instead of being down at 0, 0, it's going to be shifted up 1, 2, 3, 4. It's still going to have the same slope, be the same shape. It's just going to be shifted up 4 places. The x squared minus 7 is still going to be right in the middle, but instead of starting at 0, it's going to be shifted down 1, 2, 3, 4, 5, 6, 7. Now, just because it's a minus 7, it's not upside down. It's just moved down 7 spots. So it's going to look something like this. It's still a U, still in the middle. It's just moved down 7 places. All right? So that number being added after the square is going to take your shape and move it up or down. That's all that does, okay? And you've got a diagram in your book that kind of shows you that. So what we want to put in our notes, okay? F of x equals, let's do x squared. And instead of a c, let's do a k. Let's do x squared plus k. And then I want you to write f of x equals x squared minus k. And what that does is the plus k is going to move my parabola up k. The minus k is going to move my parabola down k. It's just going to change my vertex. My vertex isn't going to be 0, 0 anymore. It's going to be 0, negative 7, or 0, 4, depending on what that k value is. So when it asks me to graph x squared minus 2, I know that it's still going to be right in the middle. It's still going to be in the middle, but instead of starting at 0, it's going to be shifted down 1, 2 units. Other than that, it's the exact same picture. It's just shifted down 2. So when it asks me to compare the graph to my normal x squared function, all I'm going to say is that it's shifted down 2. And I'm done. Okay, I'm not super picky about how perfect your U shape is. If it needs to be skinnier or wider, I like to be able to tell when I look at it that it's skinny or wide. But if it's just getting shifted, as long as I can tell that you didn't change anything dramatically, I'm not worried about how wide it is because it's the same, it's the normal function just shifted down, right? So how about number 1 and 2 right here, these examples? X squared minus 5. Well, there's nothing in front of x squared. There's a minus 5 after x squared. So it's going to be right in the middle, but it's going to be shifted 1, 2, 3, 4, 5 units down, and it's going to have the same basic shape. All right. The next example, x squared plus 3. There's nothing in front of the x squared, so it's going to be the normal thickness. It's not going to be fat or skinny, but there's this plus 3, which means instead of starting right in the middle, it's going to be shifted up 1, 2, 3. So like my vertex on this one, I would say that my vertex, instead of 0, 0, it's 0, 3, because it's shifted up 3. On this one, my vertex would be what? 0, negative 5, because it's shifted down 5 units. Right? Told you this was an easy day, right? What happens if I add or subtract before the square? Notice the difference. Before we did ax squared plus k. But look at where this minus sign is. It's before the square. It's inside parentheses instead of after the square. And that definitely changes what it does. It's not going to move it up or down. If I look at what happens, this is my favorite one because it's so interesting the way it works. If I just have normal x squared, I've got my normal graph right here, right? If I were to like add 7 or something like that, or add 6, then it would move it up 6. If I were to minus 5, then it would shift it down 5. But I don't want to do that. What I want to do is I want to add something before the square. So I want to do like x plus 4 and then square it. So my adding is happening inside the square instead of on the outside. And look at what that did. When I added 4, instead of moving it up or down, it's this orange graph right here. It's still the same shape, but it moved it to the left 1, 2, 3, 4 places. Okay, so if I were to do plus 6, it would move it to the left 6, which is backwards because I feel like a plus should move it to the right. Well, let's see. What happens if I do minus 6? Well, that moves it to the right. So it moves it the opposite direction that you think it would, which is a common mistake you're going to make. You're going to forget, oh, it doesn't move it to the right if it's a plus, to the left if it's a negative. It does the opposite. So if I had something like f of x equaled x plus 3 squared, if the plus 3 comes before the square, then I'm not shifting up or down. I'm starting at 0, but the plus is going to move me to the left 1, 2, 3. So it's going to be the same shape. It's just going to be shifted to the left 3 spots. Okay? If I were to do f of x equals x minus 6 squared, then I'm going to still start in the middle, but the minus 6 inside before the square moves me 1, 2, 3, 4, 5, 6 places to the right, and then I draw my parabola. Okay, so it goes the opposite direction that you think it would. So let's add that to our notes. Let's put f of x equals x squared. That's my normal parent function, right? My parent, it has a vertex at 0, 0. But if I do f of x equals x plus, let's use the letter h because the book likes to do that. If I do x plus h, then that's going to shift me to the left h. And if I were to do f of x equals x minus h and then square, that would shift me to the right h units. It's the same shape, it's just shifted from where I start, okay? So let's try a couple of these ones. I don't want to do that much. We're going to have to make up our own. Okay, so if I did something like f of x equals x minus 11 squared, it's the same basic shape because nothing's happening in front of the x, right? My slope isn't changing. I'm not shifting up or down. The minus is on the inside. It comes before the square. So that means that instead of shifting to the left 11, I'm going to shift 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to the right. And it's going to be the same shape as it was before, just shifted to the right 11 places. So my vertex is what? 11, 0, because I'm over 11 and up 0. So if I had f of x equaled x plus 3 squared, then it's my same basic shape because nothing's being multiplied by x. My plus is before the square. It's on the inside. So that means instead of starting right in the middle, I'm going to go to the left. I erased again. I'm going to go to the left, 1, 2, 3, and that's where I'm going to start. Other than that, it's just going to be a normal parabola. It's just shifted to the left 3 places. So what I really want to do is I want to combine these different ideas together, okay? Because functions don't normally just get moved up or just to the right, or the slope gets steeper or flatter. Usually lots of things are happening at the same time. So for this example, it says g of x equals 1/2 multiplied by x minus 4 squared. So the 1/2, that's my a that we learned about in the last homework. And the minus 4 on the inside is going to do what? What's that minus 4 going to do? It's going to shift me 4 to the right. So let's try to draw this. If this is my normal function, right? But instead of starting at 0, 0, I'm shifting this negative right here with the 4 tells me that I'm going to shift 1, 2, 3, 4 to the right. I'm not going to shift up or down at all. I'm just shifting 4 to the right. But I also have this a out in front from homework 3.1 that we have to deal with. So from my starting point, which is this blue one right here, from my starting point, remember how to graph? The 1/2 tells me that I go over 1 and I go up whatever a is, which happens to be 1/2. So from my starting point, I'm going to go over 1 and up 1/2. So we better make a full up right there, right? So I'm going to go over 1 and I'm going to go up 1/2. And then I'm going to go over 2 and I'm going to go up 4 times a, which is 4 times 1/2, which is 2. So I'm going to go over 1, 2, and I'm going to go up 1, 2. So this one's going to be like up here somewhere. So as I draw this, it's going to look something like that. And to go the other direction, I just copy what I did the other direction. I go to the left 1 and I go up 1/2. And I go to the left 2 and I go up 4. That does not seem like it's the same, but that's okay. We're close enough, right? We'll just make that a bigger dot. And then see how good my dots are? You just have to make them bigger and then they fit. So that's what my graph would look like. The minus 4 shifts it to the right. The 1/2 makes it fat and flat, right? So I would say that because it asks me to compare. It's always going to ask me to compare. So I'm going to say it shifted to the right 4, and it has a slope. I better put that in quotations. It has a slope of 1/2, or it's fat and flat, right? It's fat and flat compared to the original one. That fraction makes it flatter. Okay, let's try a couple more. How about 2 multiplied by x plus 5 squared? So again, a lot of stuff going on. I've got a 2 in the front. That's just my a value. And then I have this plus 5 going on before the square. And that tells me that I'm going to go to the left 5. So let's try to graph this one. If I draw my table here, or my coordinates here, instead of starting right in the middle, I have to shift to the left 5. So 1, 2, 3, 4, 5. That's where I'm going to start. That's my starting point. Do we need to do that in blue again so it looks a little bit different? Now, a, because I have this number in front of the x, that changes my slope, right? That changes how steep my function is. So I'm going to go to the right 1, and I'm going to go up a, which is 2. So from my starting point right here, I'm going to go over 1, and I'm going to go up 2. And maybe we should draw those little tick marks, right? So over 1, up 2. And then I'm going to go over 2, and I'm going to go up 4 times a, which is 4 times 2, which is 8. I feel like we've done something similar to this. So I'm going to go over 1, 2, and I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And we're going to pretend like that's 8 right there. So over 2, up 8. And then I'm going to draw my beautifully curved line, right? And then I copy what I did, but the other direction. I go to the left 1, up 2, and I put a dot right there. And then I go to the left 2, up 8, and I'm going to draw this parabola, that side of the parabola. So compared to my normal graph, man, this is ugly, okay? You can say, yeah, it's uglier because I didn't draw my U very good. So what did it do? It shifted left how far? 5. And my new slope, even though it's not actually slope, my new slope is 2, or I can say that it's skinnier than it was before. It's not the normal width, it's skinnier because it's steeper and has a bigger slope. So that's going to be the second section, all right? So we kind of combined 3.1, we learned 3.2, we learned 3.4. And what I want to do is all of these at the same time. I want to do a couple examples that do all of these together. So before we do that, here's what I want you to put in your notes, okay? This is going in your notebook right here. So first thing you're going to write is f of x equals a parenthesis x minus h parenthesis squared plus k. Pause if you need to. And then we're going to just write some little reminders here. A is kind of my slope, right? If it's negative, let's not write the word negative. That takes too much space. If it's negative, then it's upside down. Instead of a U, it's an upside down U. H, this one right here, it shifts me to the right if it's negative, and it's going to shift me to the left if it's a positive number. So it's going to shift me H to the right or H to the left if it's positive or negative, depending on which one. And then K, remember, is going to shift me K up if it's positive, and it's going to shift me K down if it's a negative number. So it's going to shift me K up if it's a positive number, K down if it's a negative. So this example right here, f of x equals 3 times x plus 4 minus 6. Without even graphing it, I can describe what happens. The 3 right there tells me that my new slope is going to be 3, or I can say that that's going to make it skinnier. It's going to make it a lot skinnier graph. This plus 4 right here tells me that my graph is going to be shifted to the left 4. And this minus 6 tells me that my graph is going to be shifted down 6. So if I wanted to draw that quickly, let's see, I'm shifted to the left 4. Whoops, I drew this wrong, didn't I? We're going to go to the left and we're going to go down. So I'm shifted 1, 2, 3, 4. Instead of in the middle, I'm shifted left 4 and 1, 2, 3, 4, 5, 6 down. So this is where my graph is going to start. And it's going to be tall and skinny, right? It's going to be skinnier than normal. So it's going to look skinnier than it normally does. So it's going to look something like that. Not exactly like that, but that's a rough graph of what it's going to look like, right? Okay, so let's try a couple of these. Graph g of x equals negative 2, x plus 2 squared plus 3. All right, before I start trying to graph, I just want to go through this problem piece by piece. That negative 2 in front tells me that it's upside down, and it tells me that my slope is going, or my a value is going to be negative 2. Okay, so I'm going to be upside down, and my slope is going to be negative 2. This plus 2 tells me that I'm going to be shifted to the left 2. And the plus 3 tells me that I'm going to go up 3. So when I graph this, I'm going to go, instead of starting in the middle, I'm going to go left 1, 2, and I'm going to go up 1, 2, 3. This is where I'm going to start, okay? Now, when I graph this, I really should at least do the first 2 dots in the right place. Okay, if I were grading this, I am always going to grade the vertex. Every single time, if it's not in the right place, you're losing the points. But it's good to also look at the slope, right? This negative 2 right here tells me that when I go to the right 1, it's a negative, so I'm going to go down whatever a is. And a is 2. So on my graph, I'm going to go over 1 and down 2, and that's where I'm going to put a dot. I'm going to put a dot right there. And then that tells me that when I go over 2, I'm going to go down 4 times whatever a is, which is going to be 8. Again, I feel like we've done this number before. So I'm going to go over 1, 2, and then I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. I better draw those numbers, right? Negative 1, negative 2, negative 3, negative 4, negative 5. So my other point is going to be right here. This isn't an actual point. That was just me marking the middle, right? So when I draw this, it's going to look something like, oh, that was bad. Let's do better. It's going to look something like this, okay? We're going to pretend like that's a good curved line. And then I'm going to do the same thing going the other direction. I'm going to go to the left 1 and down 2. I'm going to put a dot right there. And then I'm going to go to the left 2, and I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put a dot there. And then I'm going to draw that curved line. See, those aren't terrible. Maybe they're a little bit bad. They're not awful, horrendous. But that's kind of what my graph looks like, relatively. You know, it's not perfect, but it's a pretty good estimate of what the graph should look like. And it wants me to compare. Well, I kind of already did, didn't I? Compared to the normal graph, it's upside down. We already said that. It has a slope, kind of 2. Wrong number. It has a slope kind of 2. Or you could say that it's skinnier. And then we are shifted to the left 2. and we shifted up 3. So it's upside down. It has a slope of 2, or it's skinnier than normal. And it shifted left and up. That kind of gives me a rough idea of what's happening in these problems, okay? So here's what I need you to do. I want you to try the homework problems, okay? This is already a long video. If you have questions, email me. I'm happy to help you out. But what I want you to do on 3.2, now this homework is going to be from 2 different sections. I need you to understand that. You're doing 2 different homeworks. 3.2, I want you to do numbers 3 through 12. So 3.2, I want you to do numbers 3 through 12. And then you're going to skip to 3.4. And I'm going to have you do, I think I wrote them down, 23 through 28, and then 31 through 34. So I want you to do numbers 23 through, what was it, 28. And I want you to do 31 through 34. So 23 through 28, 31 through 34. It's not a lot of problems. That's what, almost 15, 16 total when you put them together. That's a reasonable homework assignment. So practice these. If you have questions, email me. I'll get back to you as quick as I can.